Yes. Welcome everyone to the UB Institute for Learning Sciences speaker series. We are very happy to have you here in our first ever talk in Foster Hall, new home of Graduate School of Education. So welcome to everybody, and if you haven't yet gotten some food, feel free to go grab some. You should feel free to get up and have some food whenever you are interested. It's my pleasure to introduce Dr. Qingxiao Zheng. She has been at UB in the Institute for AI and Data Science. I was delighted to make her acquaintance through the Celery Center, the Center for Early Literacy and Responsible AI. And she does really interesting work at the intersection of human-computer interaction, learning, and sort of interface design. I think I'll let her talk more about her work, but one of the things that I find most intriguing about it is always being willing to listen to users, and that is really interesting when your users are little kids. And so I think we're going to learn a lot today, and I'm very happy to welcome Qingxiao to present.
It's a great pleasure to be here today. It's a lovely place with the snow, and I didn't expect this place is so new and fresh with the smell of the carpet. And yeah, I want to thank Chris for the generous invitation. And this is wonderful, and this is probably the last talk I would do to close out 2025. And so glad to meet so many old and new faces here. And my name is Qingxiao Zheng, and I'm currently a postdoc at UB, and I work at the AI Institute for Exceptional Education as well as the Celery. And I really work in the North Campus, and I just received my PhD degree from the University of Illinois at Champaign in year 2024. And yeah. And then moved to UB, and currently I'm also in job market, so I take it as a place to share and also practice my job talk. So my research lies in the intersection of human-computer interaction and also artificial intelligence. I focus on multimodal human AI interaction for high-stakes service context. So that is the design space I'm exploring. And today I'm excited to share some of the work I've been doing related to services that support children with special needs. So before I begin, I just want to give a quick clarification about today's topic and to set the right expectation to our audience. So this talk is not only for audiences who are interested in special education, it's also for those who are interested in AI education more broadly, especially personalized services that care delivery using multimodal AI. And even though all of the examples today I will be showing focus on communication support, the stakeholders I designed for include caregivers and parents across home, school, and clinical ecosystem. So if you work with teachers and if you work with parents, you may find this talk particularly relevant to you. So today I'll be sharing some research progress and reflections from a series of projects on designing AI technologies to support communication challenges across the developmental. Because communication is such a broad term, so let me define it first. So the exact space I'm working on in clinical fields, it is defined as difficulties in understanding or producing speech sound, forming words, or articulate sentences, or conduct proper social interactions. So in clinical terms, they call it communication disorder. But we are not in a clinical condition context today, so I will use the broad term communication challenges to refer to the difficulties children may face with speech, language, and social interaction in general. So why it is an important topic and why it is an area I want to focus on because communication is a capability that shapes everyday family interaction and social experience in school and long-term developmental outcomes. And these kind of challenges can stem from actually different reasons. For example, maybe genetic factors or from some physical problems such as brains and muscle development, or some environmental problems such as exposing to toxins during pregnancy. And the impact is, of course, very profound. It's not only on children, but also on the families that surrounding the children. But there's a golden rule that probably everyone in this education field is very familiar, is that early identification of those challenges and giving proper intervention as early as possible will help to aid to either to improve the situation or to not to make it worse. So the general population that this series works on is that we have around 3.4 million of American children. They face the speech language challenges. And those children are often referred to speech language pathologists who are experts in supporting and practicing speech language sound. And some of those children also they are referred to seeing a child psychiatrist. Those are the experts who will help in children's social, emotional, and behavior-related problems. However, the reality is that in this field, professionals there's an extremely overburdened issue and it's a burnout. And I just took some screenshot from the TikTok, and you can find some service providers, especially the junior providers. They are joking in TikTok every day, saying that they have this and that. Years leaving the field because they are so overburdened and it's just a lot of work, and not alone to mention the challenges at home and at school. So the question that I begin to ask is, how can we expand personalized communication support for children with communication challenges across home, school, and clinical ecosystem? So I just want to give first a video about some everyday intervention sessions or clinical sessions that the kids they are experiencing.
Once upon, I forgot the story.
Well, do you remember? This is going to help you.
Chad went to Tammy's house to show him his snake. Eek! Ouch! Tammy said, the snake bit me. Chad was laughing. Tammy was sad. The snake
Slithered? That's a good word. Slithered.
Downstairs.
Okay, so it's just a simple glimpse of the everyday scenario they encounter. So I put some icons there, maybe that's why I put them there. Is an eye and volume, and the third one is the mentioned as a kind of behavior. So what you see is that in this short video, there is an incredibly rich ring of communication behavior every day, and actually this is something those teachers, those clinicians, they have to deal with every day. They need to closely observe every word the child is trying to use, and every social interaction they try to try to perform. And all of those is a component that those practitioners they need to keep track of in order to identify the progress, the problems. So overall, the message I tried to convey here is that communication is fundamentally multimodal, and it is not just what they say, but it's kind of a holistic thing that the child will perform during a classroom session or a clinical session. And this naturally pushed me to ask, as a researcher in the field of human-computer interaction and artificial intelligence, what can today's state-of-the-art multimodal AI actually offer in this field? So when I talk about multimodal AI, I'm talking about a system that can take in audio, text, video, all the human behaviors, and then integrate them together, not a single separate string. They are all together. And we're already seeing some amazing advancement in using multimodal AI in our everyday life. For example, in the medical diagnosis, many of the doctors are beginning to use multimodal AI to in MRI scan and CT images. They use it to produce holistic assessment, especially in areas like radiology and oncology. And also in self-driving vehicles, we see like Tesla and Waymo fusion like camera feeds. They are incorporated with GPS and 360-degree cameras to understand the world, so we can anticipate, and the machine and the car can kind of navigate complex traffic and in the traffic environment. And also robots, probably we're more familiar with this. So currently, technologies are giving these robots the eyes to let them understand or recognize like human behavior when they were trying to communicate, and when they hear a command, and when they see the object in the surrounding environment. So all of these technologies that we probably are very familiar with are supported by the multimodal AI that can perceive the rich signals of the environment. So the inspiration from this type of technology is that if it is so advanced in scenarios that is all like mostly a high stake, can we also apply them in education context, especially special education that is also very sensitive and is highly personalized? So that brings me to today's agenda. I'm going to walk through some of my work on human-centered multimodal AI. Especially, I asked 3 questions. First, how can we build multimodal understanding of children communication in real, messy, group-based learning environment? And second is, how can we design responsible AI reasoning system that helps the clinicians or the educators to interpret what they see, and then they can make better decisions? And lastly, I will bring these capabilities, the multimodal understanding, and also the AI reasoning into the home context through the ecosystem-ready, family-centered deployment. So this is the research agenda today. So I'll first play another video, which is a group-based special education.
So every landing is connected to a takeoff. That's why you see the part of the, that's why you see that part of the rocket on the landing. I'm going to give you guys an action. You give me the landing. A boy looks for his homework. That's the landing. He finds it. Yeah. If a boy looks for.
Yeah. So just so this video is different from the earlier one because you see there are multiple kids. And actually, in the everyday clinical therapy sessions, those kids are usually grouped. And for each session, depending on the kids, physical condition or mood or status, they are actually grouped in different. So every time they may have different peers in one group. And the challenge it is posing to the professionals is that it's really hard for the professionals in a group session to coordinate, especially for those who are junior, and to take notes of each kid's performance during the session. So it poses a significant challenge for the practitioners to keep track of the kids' performance in every clinical session. So that I asked a question in the context that clinicians need to interpret those micro behaviors every minute, complex by in a group session. How can they well document all of these cues, especially those cues whether is the kid engaged, are they frustrated, were they trying to attempting to do something, are they struggling, were they trying to reach out and then to deliver something but that was missed out. during the chaotic of the classroom setting. So that prompts me to actually firstly do an initial user study with a group of specialists and service providers. And not surprisingly, all of them told us that the documentation is their invincible workload. Although they're doing like 8 to 15 back-to-back everyday workload in the daytime, they still need to sit down and then bring all of this material or notes at home to do the documentation. And then this documentation, clinical documentation, is called SOAP note. And this note is very important because it helps to keep track of how these kids, because they have special needs, how they perform, how they progress in every session. And also it's a way for them to communicate with the caregivers and families to report their progress. And most importantly, those notes is also very important to get early if the kids can receive further services when they file the insurance. So this is a very, very important documentation. And this is a template of the SOAP note. It's called SOAP note because it has four major components. One is subjective, which is the information provided by the clients or caregivers. For example, if the kid does not feel good, then they have to log those factors in the SOAP. And the second one is called objective. Those are the factual information, for example, the accuracy of when they perform, for example, they are showing the pace up, how to produce the sound in this session, and then how well the kids was able to accurately perform it. And then they have to have some numbers, accuracy percentage to record their progress. This is objective data. And the third one is assessment. Is that after all these observations, taking consideration of the kids' performance, you have to assess and then make a further planning. And it's not hard to imagine that the second one, the objective, is really difficult. Because we just saw the video that in a group-based context, really hard to really take notes and concentrate on or to pay special attention to each of the kids. So that prompted me to ask my first research question: how might AI help clinicians interpret those micro behaviors? So the first thing I do is exploring an ideal world. So if there's an AI that is so perfect, so accurate, how it can be integrated into the real world workflow. And then that's why I try to understand the whole feasibility thing. I co-designed this like an ideal world with professionals, and then let's see.
Let's walk through the final Collaborate user experience design for SOAP AI. As you and SLP log into SOAP AI, you're greeted by three key features: a video window for playback of automatically recorded sessions, a transcription window with speaker-specific transcripts, and an intelligent SLP assistant.
Hi, Selena. I identify 3 kids in your session. Is it still an articulation session for Mike? It seems Jackie is your new student. Are there any non-standard aspects to consider?
Annotations such as verbal prompts are visible directly in the transcript. For example, when Mike says, "because he fell," it indicates that this was verbalized with your prompt. The AI provides proactive, goal-based progress reports and allows for inquiries about specific session details.
There are 70% of opportunities Mike produced the K sound in the phrases accurately when given a gestural cue, that is, tapping at the back of the throat to encourage a back position of the tongue.
You can view the AI generating SOAP notes in real time for customization in the left window. In the bottom right corner, access the SLP AI assistant chat for a detailed progress report.
Since the last session, Mike's accuracy has increased from 7% to 10%, which is a clear sign of progression. With Mike achieving 70% accuracy in the last 3 sessions, it may be time to advance to the next goal.
Besides the notes, the left window offers a dynamic view of Mike's journey towards each learning objective, with a detailed progress visualization. SOAP AI provides a calendar view for easy note organization and quick report generation, from daily to yearly summaries. You can then review, revise, and share these insights with key stakeholders, keeping everyone updated on the child's progress.
So this is an ideal world. This is not a, this is a prototype, not prototype to say, but just a vision of if AI going to incorporate into the real classroom setting, how it will look like. So it's just like nowadays we have this Zoom, and then the Zoom allows us to have this automatic notes generation after each session. Like similar logic, if we can have this type of technology in the special education, we may get those notes easily. However, is the real reality that promising? Actually, we don't know given the current advancement of the technology. So I led the design of a user study with my colleagues where we want to co-explore the challenges with clinicians using the current multimodal AI to understand the challenges, the opportunities. So in a simple summary, this is a diagram of the method. We asked 17 clinicians to read AI-generated SOAP notes, and then we asked them to take their own SOAP note after they watched the video, and then we do a comparison of the AI-generated SOAP note and the human written SOAP note. And then for each of the clinicians, we actually iterate the process. From the first clinicians, we got their feedback from the AI-generated SOAP note, we gather the insight, and then we use that knowledge to re-instruct our AI model to produce a better SOAP note in the next session. And this iteration takes 17 times until we reach saturation. Feels like all the insights are good enough to report. And this is an example of think-aloud data we recorded during the session. And I color-coded different components, and basically it includes the detailed behavior analysis from the clinician and also the reasoning of why they observe that and why that observation is important. And then those are the important domain knowledge we get from the AI-generated SOAP note comparison with humans. And the findings, we really get a lot of finding, and then I'll just pick one that is really important and interesting. One of the limitations we find AI models that, for example, on the right side, that's the AI-generated analysis, and on the left side is the edited edited analysis by the clinicians. And the AI actually used the comparison word in the SOAP note because it was in a group session with 3 voice. And AI used a richer vocabulary when it was coming from the right child's behavior, whereas the clinician actually correct that into he demonstrated appropriate vocabulary. So you can see that through this modification, we learned that although that multimodal AI can describe the video, but it still misunderstands what clinicians consider socially meaningful in the context. So this meaningful social behavior has also many other forms. For example, in some of the videos, we actually have those kids with autism, and the autism kids, they actually have different sensory needs, like they have their rocking needs. They want to look around, and all of those are also engagement. But in the AI-generated SOAP notes, we find the model misinterpret those behaviors as disengaged. And then it highlighted to the professionals, which they in turn tell us this is wrong, because when we analyze this behavior, we really consider various profile, like the profile and the background and the situation, and like what kind of classroom scenario, what kind of training scenario or therapy scenario that was. So our general conclusion is that current AI, although it can see the video, it cannot see the child in the video. So it prompts us to think, how can we build up a pipeline that allows clinicians or experts to educate or co-create with AI model in a way that is progressive? So the solution is that I then designed the SOAP AI, which is a multi-model AI system that treats behavior analysis as
for coding.
process.
Upon login, an AI chatbot greets Ella, a behavior analyst.
Hello, I'm your AI assistant. I'm here to help you analyze your video sessions according to your specific needs.
Ella can upload or select a video for analysis. The system processes the video, analyzing frames and generating transcripts. After uploading, a notification prompts Ella to name individuals in the video.
Video uploaded successfully. I can see that there are 1 adult and 3 children in the video. Can you please tell me their names starting from left to right? Great. I am ready to analyze this video with Jim, Sam, David, and the therapist.
Video analysis begins by transferring behaviors from a global to a local set for personal use. These global behaviors are predefined and universally shared, intended to facilitate user collaboration. Clicking Analyze Behavior starts the AI analysis of selected behaviors.
Understood. I will analyze initiating social interaction, ISI. Feel free to ask me any questions. Here are the instances of initiating social interaction, ISI, I observed in the video.
However, without expert input, AI might not correctly interpret behaviors or adhere to established norms in specific fields. Effective AI should adapt its evaluations to suit different situations and evolving objectives. For instance, AI needs to recognize that autistic children's rocking often indicates sensory needs, not disengagement. To address this challenge, we designed the Behavior Manager feature, which has 3 input boxes for detailed behavior specifications. Ella can view, edit, and share behavior details and instances using this feature. The Behavior Name box allows Ella to add or edit behavior names. The Behavior Definition box lets Ella describe behaviors based on her expertise. For example, Ella might define responsive joint attention, or RJA, as reacting to another's cues. The instances of the Behavior box allows marking behavior occurrences with timestamps. For instance, after reviewing, Ella might mark RJA from 1.6 to 1.9. AI then drafts a segment description, which Ella can refine for accuracy.
So I just want to explain a little bit here. So the AI was able to give an initial version of the observation description for a certain timestamp, and then if they find that something is incorrect, so this is where we design the behavior manager, where the expert they can actually correct AI's misunderstanding in some of the behavior. And all the data will be this data feed will be sent to our backend, so we are able to use that data to further improve or categorize a specific type of behavior per specific trial. So that makes that progressive task feasible. So this is actually not a user interface, but the whole goal of this like a technical pipeline is allowing the domain expert to get involved in the co-learning with the AI. And then the end goal of this project is not to have an interface or solution, but the core contribution of SOAP AI is that it introduced a new concept called fluidity. So fluidity is actually a fundamental design principles that we want to argue and for multimodal AI in special education. So in our study, the speech language pathologists, the clinicians, they repeatedly emphasize that behavior does not have a single fixed meaning. Their meaning shifts depends on the task, that depends on the developmental target and the individual children. So we formalize this into 3 forms of fluidity. The first is contextual fluidity. That means the AI must interpret behavior related to what the child is doing. For example, if a child was in a session where a child was saying that was saying a word, and the word is a word that is being practiced in that session. If the AI cannot distinguish if that word was produced in a context in a spontaneous speech or a drill, then it's very difficult for the therapist to determine whether it is a skill that the kid has already developed or not. So this is a contextual fluidity, and the current multimodal AI still has some challenges in differentiating the different, goals or session within a short or like classroom session. And the second one is assessment fluidity. And a simple example is that in one of the video, a kid said, we ate lunch earlier. Like in a grammar, like you would say, oh, this is wrong. But in our interview, actually, the expert told us that in such a context, what is meaningful is not if the kids in their age, in their given scenario, the grammar is correct or not. Is that they are trying to use the past tense to convey that, oh, they ate lunch. So that is the assessment fluidity. We do not want to pose AI to force the grammatically correct rules. We want to give them the flexibility that there are different contexts we need to consider when we want to assess the kid's progress. And the last thing is the individual fluidity. And this requires AI to respect each child's sensory profile and communication style, just as earlier I mentioned about the rocking sensory needs from the autism kids. There are also other behaviors such as scripting, looking away, and fidgeting. And those are not disengagement cues for many autistic children. They are actually regulatory behavior. And there's important things that when AI treats rocking or aversion as a failure of attention, then it directly contradicts this individual fluidity because it forces a neurotypical interpretation on neurodivergent behavior, which is not a good thing. So another highlight from the user study is that we found the proposed pipeline is essentially the behavior management that I paused and explained. Is that experts actually find that this renaming, defining, and correcting, instructing AI about some specific behavior is very helpful, and they can test the AI corrected, and they can offer different concept or some very unique patterns of a specific key. They can give the AI this instructions to update its understanding in real time. So from the pilot study, clinicians describe this as owning the AI because they feel the system reflects their practice and their decisions. So the sense of ownership AI makes this AI usable in the real world. So in the user study, we also, although that we show lots of benefits, and we also show some limitations of using multimodal AI to capture the behaviors. The benefits include automatic tracking, pattern discovery, identifying disparities in group session, and also foster the clinicians them to reflect on their own teaching strategy. But the result also reveals some challenges, such as the automatic speech recognition technology. It is not so good in detecting the child's speech versus with an adult one. And most importantly, although that AI can give so rich information of the observation in a session, it's actually causing extra information burden on them because they have to review all the information AI generated. So we see that this is is it a paradox? And then is it a good thing or bad thing? How can we address that, given so much information that the AI can provide to the professionals? So this gap directly motivates my next study, which is we might use AI-generated results to help clinicians to make informed decisions directly. So if the first pillar of today's talk is about multimodal understanding, My second pillar is about after we understand this behavior, how can we support the clinicians and teachers to interpret and then make decisions together with AI's input. For example, what skills should be targeted next, and what level of support does the child need, and how do we measure this progress in a way that is meaningful, and how does that connect to the further, the clinical decisions. So that comes to the key part of the SOAP node, which is the planning. If SOAP AI can help AI to observe during the second task of the SOAP node, this next project helps AI think about those behaviors, what those behaviors means for children's development. So the question is, how my AI model experts reasoning. So you might think the easy solution is that we put all of the kids' behavior and their progress into ChatGPT or into a large language model, and then through it to the model, and including all of the history of the client history, and then getting the AI to say, oh, this is something that you can do next. But I'm using a picture here. It's a break because I want to communicate the idea is that the AI generated text is probabilistic and it's not embedded in the communication, in the domain expertise that thousands of clinicians they are trying to apply in real world context. So it's not like simply prompting AI to state, oh, what can I do next with the given information A, B, C, D. So when we the first thing we do, or the first task we try to define is that it is actually a reasoning task. And the reasoning task is very challenging because it's passive and it's cognitively very expensive. And some of the behaviors, such as the partial correct response, can mean many different things depending on the scaffold status, the children's developmental status, their profile, the disorder that they diagnose, and the instruction strategy. So all of this reasoning part is actually one of the biggest challenge or burnouts that pose to the clinicians, because every decision make counts, and then it will either accelerate the progress of the children's speech, language, and social interaction, or it may cause some negative impact if it's too fast or it's not appropriate. And in real world practice, the practitioners, they actually use evidence-based intervention, EBI, which is a program, practice, or policy that has been proven through research or evaluation. So if a strategy is being proposed and it's been several rounds of clinical evaluation, and they deem that this strategy is effective, then it's called evidence-based intervention that they can use in the actual clinical setting. But the reality is that, first of all, many of these practitioners, they receive some knowledge of this evidence-based intervention in their graduate school. And then after there's like a 2-year graduate school, they go to a practicing field, like a 1 year or 2 year, they actually go to school and have this tangible experience teaching children. And after that, it's their own decision, or it's their own, practice, whether they want to learn more about are there any new strategies that's being invented or being proposed or evaluated in this field. So there's always a disconnection between what's happening in the research area and what's happening in the school context. And I guess many of the in other education domain, this maybe is also a problem. So what we how we define this task is that instead of building a plan generator or intervention, evidence-based intervention generator, we need to build a structured reasoning support that actually mirrors how experts think. And then the idea is very simple. AI cannot decide for this expert, but at least it can give the expert some information and help them to make personalized decision on each of individual child. So in order to do that, the first thing we do is actually we collected over 64,000 research articles from public resources and systematically designed a methodology to annotate language intervention. And in total, we found over 2,000 interventions targeting various communication disorders, and we have those contextual information when we annotate these research articles. And then we use this contextual information as a knowledge base. And then we design an initial AI assistant to kind of probe how these type of connections with all the contextual information make sense to clinicians when they make the planning. So let's watch another video.
For example, Sarah, age 4, she has phonological awareness disorder. Evaluation showed that she has difficulties in rhyming segmentation, decoding of vowel sounds, and morphology. Can you recommend an intervention for her? Provide the reason and details.
Every single answer returned by our chatbot. We show the reference PDFs of this answer, and additionally, we add a new feature, so which is the reference intervention knowledge come from our knowledge graph difference. So in this use case, we have two types of reference. I think there's a connection.
Sorry about that.
So what we did is that this chatbot, it has Sarah is age 4, and then she has a phonological awareness disorder, and the evaluation showed that she has difficulties in rhythming, segmentation, decoding of vowel sounds, and morphology. So can you recommend an intervention for her and provide the reason and the details? And then this is an initial recommendation from the AI model. And then what we have is that we allow the experts to interact with AI's generated intervention by showing a knowledge graph, which has the proposed intervention and is corresponding on this ontology. This include therapy activity in relation to that intervention, and also the duration of the intervention, the procedure, the therapy goal, and then their age, their applicable setting and disorder, and also the dosage. So this, with all this information, they can change different intervention plan that the AI is generated and kind of explore the best, the one that they feel that fits most. So yeah, here is actually more clear. So here's what's happening inside the system. So the chat will start with the child's profile, their age, diagnosis, and specific area of difficulty. And then it generates an intervention recommendation that includes the objectives, activities, and the justification why this intervention is recommended. And instead of just randomly generating, the system also runs every suggestion in actual evidence, so they can actually click into each node of this corresponding information. So it shows the exact sentence in the PDF that supports the recommendation, and then link to the small knowledge graph of the concept. So what you see here is actually a transparent reasoning chain from child's profile to their intervention, to their evidence, to the exact citation and the knowledge graph. So everything the system says can be tracked, traced, and justified. And currently, this is the backend of the system, and then we are exploring a reasoning space where AI can make taxic reasoning visible and shareable. So actually, this is a work in progress. Currently, I'm designing this new system called SmartGo AI, which is exploring a reasoning space in design where AI can make those taxi reasoning visible, and how can we do human-centered AI to allow experts to see this rationale, they can modify it, and they can adapt to the child's profile. So this is the work that currently we are working on. So if the Pillar 1 helps AI see what's happening in the classroom or in a therapy session, Pillar 2 helps AI think about what it means and what might come next in the planning. And the third part is that how can we take this expert-line evidence-based reasoning in combination with all of the multimodal understanding from the clinical school setting to a home environment. So this is the Pillar 3 that I'm exploring. So far, this is actually a transition from the school setting, clinical setting to the home. And because the home is a huge part, it's a place where a huge part of communication that happens and is so natural that it occurs every day. So we want to try to test out if the same solution, the same pipeline will still work in a home environment. If it works, then it's great, but is there something that is different? Then this is a problem this is a research question that we want to discover. But once the setting is determined and we start to probing what kind of question, what kind of challenges is happening in the home intervention setting, and then general the biggest challenge is that many parents, they struggled with using this effective strategy at home. Because of the wrong reasons, first off, they may not be aware that there are many of the evidence-based or effective training strategy that they can apply easily. They don't have the awareness. And second is that even though they have that awareness, they don't know how to implement it. They don't have the training from the professionals because the professionals are already overburdened with supporting the kids. So families are always in most cases on their own to seek support either from the community or from some courses they can take. So I asked this question: how can we extend expert-aligned multimodal AI to empower families directly in a way that are accessible, evidence-based, and personalized inside the messy rhythm of daily life? So some background. So I mentioned that there are many available strategies that can be applied at home. This is just one example. This is called modeling, one of the naturalistic developmental behavior intervention strategy. And modeling is easy to understand. It's just the learner imitates or target behavior performed by a model. And similarly, we also have man model, which is another version of modeling. The man model is really using a verbal prompt when you do the model, such as you can ask open-ended question and a choice question, or just simply give the direction. So those are the widely applied or effective strategies that have been studied in the research field. However, even though we have all of those amazing tips there or strategy there, the key to determine whether this strategy works in realistic context is that if the parents can implement them with high fidelity. High fidelity means that if they can actually follow the procedure or follow the exact, the instructions from the strategy. For example, here on the left, on the right, I show a diagram, which is which is a serious step to increase the child's use of developing communication skill. The first step is that establishing drawing attention, and then like in a story reading setting, first that they will see catch the child's attention and then ask a serious question. If the kid does not respond, they have different coping strategies. First, if the kids respond correctly, there's the next step is maybe to acknowledge them. If the kid does not answer or does not respond, they have a time delay strategy, which is ask the parent to wait for at least 3 seconds to give them time to think and then to catch their attention. So although this is easy, this is all in that diagram, but in reality the parent doesn't follow this in a way. And then in some situations they thought that they follow this, but in fact maybe it's not that strictly following this procedure that caused the failure of applying some effective strategies. So, what is the current status in this home intervention field? Is that some of the services available is teletherapy, and then in this therapy sessions, usually there is a service provider like a behavior analyst. They receive a video recording of the parents doing story time at home with their kids. And then they will just play the video, share the Zoom screen, and then they will comment on, at a certain time point you didn't wait enough time, so maybe next time you wait for at least 3 seconds to give your kids a time to think and to react to you. And also they give this. They also show some of the diagrams that earlier I just showed to reinforce parents' memory on all of those strategies. However, for many families, the reality is that, especially those in rural areas, the culturally diverse household, the family may face a long waiting time to get those kind of services, because some of the services will only provide to the family free once they have diagnosed that. But there's a long waiting period between the assessment and the diagnostic result. So, and also many of the parents, they don't aware that there is such service available there, and this creates a major equity gap. Is that a family who possibly could benefit most from those are the least able to access them. So here, this is a video without sound. So here is an example, and the first step we do is actually we gather a lot of the videos. It's from one of the experts we collaborate with, Yusuf. He has a bunch of video data, and then this video data has been annotated as he's interacting in story time at home, and parents was doing the home intervention. And then we train the model to recognize the strategy. You see this on the top. There is the timeline shows the exact moment our model detects the use of each of the strategies, such as model, man model, and time delay. And with this capability, our next thing we do is actually based on this model, we designed this human-centered AI system named the PiCoach, Parents AI Coach. And that supports parents in practicing those evidence-based communication strategy inside a natural routine. And the system actually invites parents to upload a short video from home, and often during a shared storytelling moment, because storytelling and story reading is a familiar and low stress routine for many families. So we use it as an example routine in the study. And instead of trying to replace the coach or the coach of existing services, the system is positioned to be focusing on guiding and then reflecting, and then it provides real-time feedback so that the parents doesn't have to wait for 2 weeks and or months in order to get feedback from the next clinical session. So it's actually it takes a long time. It's almost more than a year that I co-designed this pi coach with multi-stakeholders that includes parents, service providers, including speech language pathologists, special education teacher, and those who work in behavior-based analysis and intervention. And also, we deployed this system with parent-child dyads, and then they actually use this system over a 2-week period, and then we do the parent testing, and this is system user workflow. And oh my God, are you aware that's the time limit? Okay, I'm going to hurry up. So we were surprised that the parents was able to use that for the 2-week deployment, and it shows amazing. Like currently just 2 week, a short term, not long term, but the linear mixed effect model show there's significant improvement in the overall fidelity score. And then we also see that parents give us positive feedback, such as they feel like they don't have that hesitation to reach out to an AI compared reaching out to their human professional service providers. And then they usually, as a parent, they don't receive feedback like you are doing great. But from the AI, they receive that encouragement, which means a lot to them. It's kind of providing the emotional support. And this is a collaborative work with my colleagues, Dr. Qingxiao Zheng and Zhang Hui. And we actually have great news to share is that we got another grant from the Organization for Autism Research. And I'm a co-PI in this project, and we are going to do further clinical evaluation on this system. So yeah, so just to quickly wrap up in today's talk, I mentioned these 3 pillars. And but I want to mention that each of this project is not an end point, and there are early prototypes of a larger research agenda. But what they show collectively is that supporting communication disorder at scale require more than one single model or a single platform. It requires an AI infrastructure that I put here that requires multiple observation, reasoning, and real-time deployment in the whole ecosystem. And this work is just a part of a much larger, bigger architecture in my research. And over the years, I've designed and studied human-centered AI across many contexts, from public libraries to law enforcement training, and to medical simulation using virtual reality, and also AI-supported learning and technology for social connection and well-being. So this project, one common thing that I experience again from all this project is that people work in complex multimodal environment. They rely on taxi expertise, they need transparency, and all of the AI must enhance but not to replace human judgment. So this is a broader portfolio, shows that I'm not only building system, I'm building a generalized method for designing AI that work in real world with real people, real constraints, and real consequences. And yeah, so to close, I want to share some of the future work is, for example, developing model children's social and communicative learning in natural settings, and this opens opportunity to collaborate with learning scientists and early researchers. And also, I'm interested in broadening in making taxi decisions visible and to support children learning across contexts because they are not learn things in silos. So I'm happy to keep working on these directions. I'm excited to explore further collaboration opportunities with communities and with the audience here today. Yeah, this is the last minute. Thank you.
And we might have time for a quick question if somebody wants to probe a bit. I know I have a whole list of questions, but I get to ask her later.
Any questions or if I'm curious in any of this project, I'm happy to answer.
I'm not sure if I captured it right, but did you create the AI, the parent AI?
Yeah, I'm
yourself.
Yeah, this is a mobile-based app, and I'm the lead designer for that.
How did you what inspired you to create it?
Because as I said, thank you. So these families, they at home, they don't know how to implement those strategies effectively. If use time like hesitating if they are doing the right thing, it actually delay their child in taking the best opportunity and time to make the intervention. And also, many of them, they are hesitant to reach out to professionals. Either they are afraid of the high cost, or they don't aware that there are specialized service in this domain. So we just want to create, initially, actually, this is a web-based app, but after the user study, I decided to turn it into a mobile one because everyone has a phone and it's more accessible. And when you take these videos, you don't have to ask them to upload it in the laptop, in the case that they don't have this technology accessible with them. So that's the whole, the general motivation that we're trying to create this technology.
Well, we're going to say thank you, and one more time. We'll also remind people there is another UBILS talk. We don't usually have them so quick right after each other, but Monday, Jason Yip from the University of Washington is coming to talk about participatory design with kids and families, and we're really excited to host him as well. So please save room for another eggplant sandwich or lunch of your choice. And if anybody forgot to sign up on the sign-up sheets out there, please do. That gets you on our mailing list, and it also allows us to prove that we didn't eat all the sandwiches ourselves. So we appreciate you signing up. For those who are engaged with the Institute, I will introduce a new face. Lindsay Galson, our operations manager, is going on leave very shortly, and in the meantime, Dima Abbas here is going to be helping fill in with some of the administrative aspects of our institute. So if you are used to communicating with Lindsay, you'll also be communicating with Dima now too. So thanks everybody for coming, and please take sandwiches. That's great. Anyone?